Shana, which question number it is?
Question part A, question 6.
In part A, which question?
6.
Okay. You can see my screen, right?
Yeah.
Okay. So in the diagram, 6 squares form a 2 cross 3 grid. The middle square in the top row is marked with an R. Each of the 5 remaining squares is to be marked with an R, S, or T. In how many ways can the grid be completed so that it includes at least one pair of squares side by side in the same row or same column that contain the same letter? For example, you have to use R, S, and T. So you have to get it like R, R, S, S.
Yeah.
Like that. Like S, S, T, T, default. So it could be column, like row, left to right is row and top to bottom is column. So that is our question. So first let's look at the possible number of choices. So in the grid there are 5 empty cells, right?
Yeah.
So in the grid you have 5 empty cells and you do have 3 choices of letter, which means R can be filled in these 5 positions. S can be filled in these 5 empty positions. T can also be filled in these 5 empty positions. So there are 3 letters, 5 options. So it's going to be like 3 raised to the power 5, which is like 3 times 3 times 3 times 3 times 3.
Yeah.
So that would be 243. So there are 243 possible grids. And so they're asking us to find one pair of squares side by side in the same row or same column, right? And that should contain same letter. So what if you have, we'll go case by case, one by one. So the case 1 is, what if you have S over here in the top left, also in the bottom middle you're having S. So for this option itself, for this case itself, S, R, S, S, R, S. So this position is going to be constant. Let's just try to fill the other letters. So you're going to keep R over here and here, T over here. And you can also change them. Like R, R, S. There is no restriction also for the number of S. You can also put like T over here and T over here. So you have many options, right? Look at the next case. You're going to place T over here and T over here and R. So in this case, they're saying there are 6 configurations in the case 1. And this can be obtained from those in case 1 by changing the T's to S's and S's to T's in the list of possibilities in case 1. You're changing S to T. How do you change that?
So like for example, for this one, it would be S R R.
Mhm.
And then for the next one, it could be T
Uh,
R T T R.
yeah, you get it, right? So
Yeah.
that's another possibilities. And now we wanna use different letters. And what if one is S and another one is T? Okay.
Okay.
So we just want to keep this as S and this as T. You see it here. You're changing this as T. Similarly, this as T. This is T. Is it clear?
Yeah.
You cannot find the pair. You cannot find the pair here, right? They are not.
Yeah. There's
constant
nothing
pair.
touching.
Yes. And like, what if vice versa? Like, what if TS, right? So for TS also. Okay. I want to know. I want to know like why it's not possible over uh, here. Why you cannot apply case 3 over here?
Because you can't put the T beside this T, or
Like you'll get,
you'll get two T's beside each other.
or it's like 2 S's, isn't it?
Yeah, if you put S here, then these two are touching. But if you
Yes.
put T here, these two are touching. So you have to put
Yes.
R there and R S here or R here. And then here you can put whatever you didn't put here.
Yeah. You understood this, right? So now if you just check the total number of options, you do have like 6 plus 6 in the case 1 and case 2. In case 3 and case 4, you will have 3 and 3. So together it is 18 configurations, which there are no two side-by-side cells that contain same letter. It's clear, right? And they say totally there are 243. 3 raised to the power 5 is 243 options. So for finding the two side by side, this is like a probability. For finding the side by side, we are subtracting the total number of the grids minus no two side by side. Is it clear?
Yeah.
So it's 3 raised to the power 5 minus 8, which is like 243 minus 8, which is 2. Clear? Okay. Okay, so part A is clear. What do we have to discuss from part B? Shana,
Yeah.
what do we have to discuss from part B?
There's B2 and B3.
B 2 and 3. Could you please read the question number 2 for me?
The symbol n factorial represents the product of the positive integers from 1 to n. That is, n factorial equals n times n minus 1 times n minus 2 times all the way to 3 times 2 times
Yeah.
1. The symbol n factorial is read n factorial. For example, the value 4 factorial is 24 because 4 times 3 times 2 times 1 equals 24. Determine the value of 7 factorial over 5 factorial.
You have learned this NPR NCR formula before, right?
Yeah.
And the factorial also you are aware. Like n factorial means it will go from like n into n minus 1, it goes on up to 1, isn't it? So when they say 7 factorial, so you have to write 7 times 6, and you have to deduce another value 5, 4, 3, 2, will go up to 1. So if you multiply all of them, you will get 5040. And 5 factorial is also 5 times 4 times 3 times 2 times 1, which is 120. So you just have to divide them. You will get the answer is 49.
Yeah.
Or if you wanna reduce the time in performing the multiplication, you can just simply express the 7 factorial as like 7 times 6 times 5 factorial over 5 factorial. Just cut
Yeah,
5
so it will
factorial and
cancel
5
out.
factorial, it will be like 42. So this is another way of doing it. You don't have to waste time in multiplication.
Yeah.
Okay. And about 98. So 98 also, like, it goes on up to, what is the subdivision B? And it's pretty easy. So 98 into 9900 is equal to n factorial. So the way you express matter, so 98 can be written as like 98, 97, 96, and all the way up to 1.
And 9,900
Yeah.
is 100 times 9.
Yeah. And that is not factorial. Okay. So 9900 can be written as like 100 times 99. And you can just rearrange them, like you can just place them in the order, like you can write it like 100 times 99, you just changing them in the like descending order, and if you
Yeah.
cut it, it is like an expansion of the 100 factorial, right? So 100
Yeah.
factorial is equal to n factorial, means the value of n is 100. Is it clear?
Yeah.
I'll give you a question based on factorial, you see whether you are able to solve. Can you try this?
So, so A equals 81.
81. Yes, yes, very good. I'll give you a little more complicated one.
Okay.
You just give a try, I'll solve it if you're not. Can you try this one?
Okay.
I'll give you a clue. Okay. For solving this question, you have to group the odd values and even values separately. Okay, this is the clue.
Okay.
Do you need my help?
Yeah, I can't really.
Okay.
I'm getting like this factorial, and this is also.
Basically, you have to prove whether left hand side is equal to right hand side or not. No problem. We'll just take
Oh
the.
wait, I have an idea.
Okay.
Okay, so then this is equal to 2 minus n 2n minus 1 factorial, right? So then if you divide this thing,
Mm-hmm.
so if you divide both sides by 2n minus 1. Then you have 2n over n factorial, right?
You don't have to solve both at a time. You can solve either of the side and you can prove left hand side is equal to right hand side or right hand side is equal to left hand side.
Okay.
Yeah. Okay.
Is this 2 to the power n?
Actually, like you can change your left hand side because you can express 2n factorial as 2n minus 1 as well, right? So if
Yeah.
you take the left hand side, you can write the numerator as like 1 into 2 into 3 into 4, like it goes like 2n minus 2, 2n minus 1, and all the way up to 2n over n factorial. Let's keep n factorial as n factorial itself. I gave you a clue that you have to group the odd values and even values separately, right? So you can do it like 1 times 3 times 5, like and so on, up to 2 times of n minus 1 into, and the even numbers can be written like 2 times 4 times 6, goes on up to like 2n minus 2 times 2n, right? Over n factorial. Shall I erase this? Did you copy the question?
Yeah.
So now I can take the 2 outside from the even part. Let's keep the odd part as it is. I mean, the odd part is this, and take the 2 outside from the even part. That would be like 1 times 2 into 3, like of course like n minus 1 times n over n factorial. Basically, like you can say you are taking like too many 2's outside, right? So you can just, you're not putting plus in between, means like you can actually write this as 2 raised to the power n. Did you get that?
Yeah.
So if you simplify this further, you can rewrite the entire expansion as n factorial, isn't it? So it's like 1 times 3 times, like it goes like 2 to n minus 1 times 2 raised to the power n into n factorial over n factorial. This n factorial and this n factorial will cancel out each other. So you'll be left with like 2 raised to the power n, like 1 into 3 into 5, like it goes like up to like 2n minus 1 times 2 power n times n factorial. Right. Yeah, I think you got the right answer part of the question. Is it clear? Is it clear, Shana?
Yeah. We just cancel the, once you divide by 2, you can cancel everything out.
Yeah. Shall I erase them?
Yeah.
Okay. Now can you try the C from this?
Question C.
Like from the 2. Like m plus 2 factorial by m factorial is equal to 40200.
Yeah. Oh, okay. Maybe I get it.
I'll just send you the other link if the meeting ends.
Yeah. Can you send it to the other phone? because my mom has the other one.
No problem. I'll send it. Actually, like, is it okay? Like, if you send me the link now, because like this one I'll be connecting the phone. I won't be able to record it. Like, can you create a meeting ID and send it to me? Like, you can record that part. Will that work? Shana?
Yeah, I can. Yeah, my mic was off. Sorry. Yeah, I can do that. I'll
No
send you a link from the phone.
Okay. We do have 3 more minutes. We can just discuss
All right.
that. So it's m plus 2 factorial. They are just writing the m plus 2 as from 1 to m plus 2. Okay. So they are just writing in the other way, like m plus 2, m plus 1, m into m minus 1. It's you're just reducing the terms and it goes on up to 1. And in the denominator, you do have m factorial. And what you can do is you can write, you have this 1, 2, 3, it goes on up to m, right? You can just segregate this part into m factorial so that like you can cancel out the m in the numerator and the denominator. So now you're just left with these two factors, which is m plus 2 and m plus 1. So now you just have to equate it and factorize it, you will find the value. Can you try this from here?
So m plus 2 factorial is the same as m factorial times m plus 2 and m plus 1. So then the m factorial cancels out in the bottom and the top, and you just have m plus 2 times m plus 1. So 440,200. So one way to do that, so we have to find two numbers that multiply to 4,200 with the one difference, right? So then 200 and 201 are the only two numbers that have one difference. So then m plus 1 is 200 and m plus 2 is 201. So m is 1,999. I mean 199.
Yeah. So which is like 40200.
Yeah.
So you can easily find the value of m by just equating one of the factors to 200. M is 199. Okay. I think the second one is also easy. It's just like how you're basically arranging them to simplify. Okay. So it's q plus 2 factorial minus q plus 1 factorial is equal to q factorial times r. They're just rewriting it. They're rewriting it as r is equal to q factorial is in multiplication. If you just push it to the other side, it becomes like denominator. And they are splitting the denominator for both the numerators. So it's q plus 2 factorial over q factorial minus q plus 1 factorial by q factorial.
Okay.
And again, like you can rewrite this q plus 2 factorial as like q plus 2 times q plus 1 into q factorial. The denominator q factorial and this factorial will cancel out each other. You will be left with this for this part. And again, you just got to repeat the same thing for here as well. So it's q plus 1